Okay, question 10, probability. What do we got here? 10.1, A and B are independent events. Probability of A is equal to a third. Probability of B is equal to 3/4. Determine the probability of A and B. Okay. Oops. So, probability of A and B for independent events, that is equal to the probability of A times the probability of B. Yes, you do get this on the formula sheet, but you know my rule. If you need a formula sheet, you haven't practiced enough. Okay, so probability of that, very simple. We're just going to go a third times 3/4, which is going to give me 3/12, which is going to give me a quarter. Okay, fantastic. Then it says 10.1.2. The probability at least one event occurs. Okay, so we can look at this in two ways. First of all, terminology. At least one of the events occur. That's the same as saying all. Okay, or you can also look at it as a Venn diagram. Okay, so normally what happens is if you have an overlap, the probability of at least one event occurring would be this area here, the probability of all these added together. Okay, which is also the probability of A or B. Okay, so you could have looked at it as from wording perspective, or you could have also looked at it from a Venn diagram perspective. So this would be the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now, people would say, but James, how do you know to use the inclusive formula here? Well, guys, a mutually exclusive formula will never ever be independent or dependent because it doesn't have an and. So immediately, because it's independent, I know I can therefore use the inclusive formula because the inclusive formula only works with independent and dependent events. Okay, so probability of A or B is what we are trying to solve for. Probability of A is a third. Probability of B is 3/4 minus the probability of 1/4. And let's see what the calculator gives us here. It is 5/6. Okay, and that is the answer to 10.1.2. Done and dusted. Let's go on to 10.2. The probability that it will snow on the Drakensberg Mountains in June is 5%. When it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 72%. If it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 is 35%. Represent the given information in a tree diagram, clearly indicating the probabilities associated with each branch. Okay, cool. So, first things first. Two different events happening here. The first one that we're going to figure out is whether it's going to snow or not. So snow and no snow. Chances that it snow is 5%. Chances that it doesn't snow is 95%. After that, we've got the temperatures going below 0 degrees. So let's say here, below 0 degrees and not, below 0 degrees and not. Okay. So what we're going to go is percentage-wise. So what did it say in the first thing? It said 72% if it does snow. So when it snows on the mountain, the probability that the minimum temperature will drop below 0 is 72%. So 72% here, which makes 28% there. And then if it doesn't snow, we're going to have a 35% and a 60%. 65%, sorry. Okay, so probabilities going straight from there, you would put those into your calculator. Remember, guys, if we go this way on a tree diagram, we times. If we're going that way on a tree diagram, we plus. Okay, so if I'm working out this one's probability, it would be 5% times 72%. Okay, so I'm going to put that in just so that you guys can see. So it is 5% times 72%. This one over here is 5% times 28%. This one is 95% times 35%. This one is 95% times 65%. and we can give those probabilities now. So equals, 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 equals. Let's just rub this out quickly. Let's just get rid of it. Okay, and I'll do it on the side here. So I'll say to you here, these we plus if we're looking for probabilities. So now that would give us 0.72. Nope, we don't need to do those results. Normally they do ask you to do the results. Let's put them in just for argument's sake. So 5% times 72% is equal to 0.036. 5% times 28% is 0.014. 95% times 35% is equal to 0.3325. And then the last one, 95% times 65% equals 0.6175. Okay, so those are probabilities, okay, associated with each branch. Now we can answer our question. So now we can say 10.2.2 is asking us, calculate the probability that the temperature in Central Africa will not drop below 0 in June 2024. So now we are going to follow certain branches. Not going to, so if it snows and not, that's the branch we're going to follow. And if it snows and doesn't drop below, that is the branch we're going to follow. So remember, when we're taking probabilities, we are going to add. So therefore, how would we write this? We can say that the probability of not below 0 degrees is going to equal 0.014 plus 0.6175, which is going to equal 0.6315. Okay, and that is your probability answers. And that is question 10.2 done. Okay, tree diagram question. Not so bad, not so difficult. Okay, 10.3, what do we got? Okay, so we got some counting principle and factorials going here. 10.3.1, we've got 10 learners stand randomly in a line, one behind the other. Okay, in how many different ways can the 10 learners stand in a line? Okay, easy question. Normally starts like that, 10 factorial. Okay, and we don't need to do it in our calculator, guys, because the factorial is going to be massive. If you want to, you can put the answer in 3628800. That is what 10 factorial is. Okay, the next one, 10.3.2. Calculate the probability that there will be 5 learners between the two youngest learners in the line. Okay, so let's draw this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. Now, let's say the first scenario. So they're saying 5 learners between the two youngest learners. So let's call this one the youngest, one of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, cool. And that's the other youngest. That is our first scenario. Do you agree? So the scenario that we have is that these two guys obviously can be there, right? So let's take this as our first scenario. And we have how many? We've got 1, 2, 3, 4, 5, 6, 7, and 8. So the red can be rearranged in 8 different ways. Okay, so the red would act as an 8 factorial. Okay, and then you would say 2 factorial for the two boys, the youngest boys that can be. So they can switch, basically, is what I'm trying to say. There's 2 scenarios. Okay, but that is obviously the one. So that is the scenario where you have 5 people in between the 2 youngest people in the line. Okay, but obviously these positions can now shift up. So now what can happen is this youngest one can move here and that youngest one can move there. Okay, then you have the scenario. Then you can say that one moves there and that one moves there. And then the last one is that one moves there and that one moves there. Okay, and then what would happen then is you would then move it back. So the first scenario is fine, and then you have another 3 different scenarios that is going to take place. I'm going to draw them out for you so that you can see them, so it's a little bit more explained. So what I'm going to do is I'm going to draw another 10 in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what I'm going to do is I'm actually going to copy that another time, and I'm going to copy it another time, just so that you can see the different scenarios that are going to take place here. So obviously this was scenario number 1. This is scenario number 2, scenario number 3, and scenario number 4. Okay, so the youngest has now moved across. So there's the youngest, and the youngest is now over here. Then the next one is the youngest is at 3, and the youngest is here. And the next one, youngest is at 4, and the youngest is last. Okay, and then these are your other people. Okay, that can all be rearranged. Okay, so those are the different scenarios that we can have. But the probability for each row remains the same. It's 2 factorial times 8 factorial, because it's still 2 youngsters that can be rearranged, as well as the 8 other people that can be rearranged. So we are just timesing those probabilities for each row by the amount of changes that can happen. So how many changes are there? There is 1, 2, 3, 4 changes. So we're taking this probability and we are going to times it. So 2 factorial times 8 factorial, and we're going to times it by 4. And we are obviously, because they're asking for the probability, we are then going to put that over the total outcomes, which is the 10 factorial. So your answer is going to be fraction 4, 2 factorial times 8 factorial all over 10 factorial, and your probability is going to be 4 over 45, which is equal to decimals 0,089. Okay, normally they don't want the decimals, so let's leave that out, and let's just keep it as the fraction, and that would be your final answer. Okay, so normally with probabilities, guys, the more you draw and the more you act it out, the more you'll understand it. But basically that would be the scenario for 10.3.2. Okay, awesome. And that is your paper finished. Can you believe it? Great. Stay tuned for more on the next paper 2. So it would be November 2023 paper 2.